Right. So Maven is actually called as build management tool, and for Maven specifically, you use it for building your projects. So when I say building your projects, I mean whatever code or project which you create, or a combination of projects, not only single project. If you have multiple projects as well and you want to build it and deploy it, right? So building here simply means that when you create a project, when you write your code inside that project, you would like to make it available to the end customer, right? So where you would make it available, right? Usually if it is a web application, you're writing it in Java, serverless and all, you would like to deploy it onto a server, and from that server someone will can then access it, right? So creation of a code is one thing. As a developer, you are liable to create the code, but you're also supposed to be thinking in the terms of how you will build the tool, building, and how you will deploy the tool. Once you do a deployment, then the end customer can actually use it, right? Now how this all fits in the development environment, it works pretty, I mean, it's very understandable there. Why? Because you go and create developer will write code, and once he or she writes code, it has to be built, right? Built simply means here conversion to a jar file or war file. Now when that happens, then it needs to be deployed somewhere, and once it's deployed, someone can access it. How it fits in your context, automation testing concepts, in a very similar way. That is, you are writing your test cases, you're creating a framework, and once you create the framework, you would like it to be executed. So when you want to execute it, before you execute it, it has to be built first, right? Built simply means you have to compile the code. Compilation of the code into a single file or in a collection of files is actually called as building process. And then once you build it, then you have to deploy it. But in automation context, you don't really have to deploy it anywhere. It actually just executes just after the project is built, right? So remember these two terms. One is build or building, and second is deploy. So you do not do deploy. Okay, you don't deploy this, you don't do this, but you only do building. And when you do building, just after that you do execution. So in the case of actual development code, you do a building and then you deploy it also, right? Once it is deployed, then it is available to the end customer. End customer can be the live customer, or it can also be a testers. Like the developer has to write the code and they have to deploy the functionality, and then they will give it to the testers, and then testers will actually perform operations on it to test the application, right? In that case also, developer will have to build it first and then deploy it. So once they deploy it, then it's available to the person who can actually use it. But in the context of the automation testing, because automation testing, you also write code, and it also has to be built, because if you're writing code in Java, you have to build it, but you don't deploy it anywhere. You rather, instead of deployment, you do execution, or here in this case we can say test execution. Okay, fair enough, guys? You understand these terms, building, deploy? If not, then you just ping me in the group, or you just unmute yourself and say that I didn't get what you just said. Okay, now this building process, I just tried to repeat this. As I said, repetition has its own importance. So this building is nothing but the compilation. So once you write the code, this is actually the source code. Okay, if you want to run this code, then you need to first compile it. And when you compile it, only then you can actually execute it. And that compilation, actually, if you compile a single file, you can say I'm compiling it. But if you want to compile a whole project, then you say I am building it. So compilation is synonymous to building. Okay. Now, this was supposed to be a very complicated process if you have a big project or a collection of projects, right? So if you have 10 projects and all the projects you have to go and build the project first, it is very, very complicated thing to do. I'll tell you a brief example of how previously people used to build it. Okay, let me just tell you that first, so it makes more sense. Now this is the project you have done, but now what you want is that you'll say, okay, my project is completed. This is my addition project, and here I have a main method in my this particular file. Let's see if it runs. Let me just right click here and see. By the way, this project we created when I think in last class. I tried explaining this. So this is working, right? So it is taking value as 7, giving the answers as this. So this is a working project, but now I want this project to be executed onto my dad's system or my sister's machine or my brother's machine. I don't have to pass the source code to them, right? It doesn't make sense for I will ask them, okay, dad, could you please install Eclipse, and then I will give you this code, and then you just go and right click and do a run. Should I do that? Should I say this to my dad who is not aware of these functionalities? Same holds true when you want to deliver something to your client. Client doesn't care what code you have written. He will not download Eclipse, right? So you have to deliver your code to your client, but in a proper format, right? So what you're going to do is you're going to build it, right? Compile it, build it, create something, create an artifact so that you can distribute it. Okay. How to do that? So previously, the old way of doing it is you kind of create the project, then you do a right click, then you go and click export. When you do an export, you get an option runnable jar file. So I think if you have familiar with Java, jar file is very famous. Jar file simply is like the collection of the class files. Like you want to send a lot of files to someone, what you do, you zip the files, right? You put it into a folder, and then you do a right click and you say compress and convert it to zip, and you make a zip file and then you pass it on to the email. It is something of similar nature. So jar file here is nothing but the compiled version of the code. It is not a zip file necessarily, it is the compiled version. So when you compile a code, this is your source code. When you compile it, it gets converted to a bytecode. So two new terms here, source code and bytecode. This is source code. When you convert it, it becomes a bytecode. If you want to see the bytecode for this, it's very easy. You have to open the workspace. Then inside workspace, you will see two folders, src and bin. If you go inside src, you will see this in two files called as .java files. But if you go into bin, you will see .class files with the same name. In the .class files, that is actually your bytecode. That is a compiled version of it. But that is scattered, right? You will see it inside. Maybe if I can show you, let's see. It's good if I could show you. So source, I think this is Maven project, doesn't make sense. Let me go, maybe check it here. 1 minute. Okay, so this is what it is. So do you see this my project here? This is my project. Inside this, I have two folders, bin and src. The src is the one where I have these files here, which you see in the form of .java files. But in the bin folder, I have the same files, but now this time these files are .class files, if you see here. So the files are same but .class. So this is actually my source code, which if I go and open in the notepad, I could see the code there. I could see the English written, sorry, syntax is in English written there. That actually is my source code. But these files, if I try to open them, you will find gibberish there, nothing good written. You will not be able to read that. That actually is a bytecode, right? So compilation in Java is a process where the source code gets converted to a bytecode. Okay, but how would you send these files? If I want my father to run this, I would have to send these files to my father and ask him, see, these are 4 files and my code is written somewhere here in my first class, and you just run this file by these many steps and it would run. Again, more technical things, lot more technical things to tell to my father or my client. Not good. So what I do is I would create a jar file. A compiled version of the whole classes and projects is actually called a jar file. Okay. How to create that jar file is what I'm going to talk about next. So I'll go to here and I will click on export and I will come here. Then I will go into search for runnable jar file. Just type runnable jar file, you'll get this. Once you find this, you click on next. Then you have to select here. In your case, if you're doing it for the first time, you will find it blank. Then you select my first project, my first class, my project here. Why we have to set this? Because you need to tell the jar file, because I'm making a runnable jar file, a file which could run, right? So I need to mention the class name in which I have a main method, because for Java you need to have something called as main method, otherwise nothing would be executed. So main method acts as a starting point of a Java program, and here in my case, this is my main method kept inside my first class basically. Okay, now here I need to mention the export destination, and this is like I have kept inside akashdktyagi my calc.jar, like at the root directory. You can choose, browse your own. Then here are the jar files, which I have added as a library, external library, right? So you can choose to extract them. I'm getting some disturbance. Can you all go on mute if you're not speaking? Okay, thank you. Now, extract acquired libraries into generated jar. This is a good option because you don't want to have them kept separately somewhere else. In our case, we really don't have any external libraries which we have added here, right? So we'll simply keep it like this, and we actually go and click on finish. As soon as you do that, right now I already exported this earlier, so I'm getting this, but in your case, you will not get this. You just click on yes or whatever pop-up it would give you. And when that happens, I would see, or you would see, if you do it, there would be a jar file being created. Where is it? I'm in my root directory. Yes. Let me find it. It must be somewhere here. Yeah, this is the file, my calc.jar file. Now this file, I can give it to my father, and I would just simply say, this is the jar file, this is the whole code and application. And if you want to run it, these are the steps. I'll tell you what are the steps, but now I have a single file which I could pass on. And this is the usual process previously, many years back, when people had to create these kind of jar files manually, and this has to be distributed manually, right? And then after distribution, it has to be deployed manually, and then it used to work on the servers, which is again a very cumbersome task to do, and very time taking, and very error prone. Not good way to do. And that's when the need of these tools called as Ant and Maven, or in general called as build management tools, came into picture. That means these tools facilitates any projects in creation of their builds automatically. So really nothing has to be done of this sort, where you have to you have to build and deploy and all those things. You have to do it manually. The Maven will take care of all of these things automatically, apart from many other things, of course, but primarily it is used as a build management tool. So the project which you are doing, you have to create in such a manner, there's a structure to it. If you follow that structure, you really don't have to worry about building as well as deploying. It just does everything on its own. But before I jump onto that, let me just try to show you how my father will execute it. And if you want to execute it, how you will do that. So what I would do, I would open the terminal like this. In my case, I'm using Mac, but your case, you will be using command line, CMD. Just type CMD and navigate to the folder. Wherever you are saving this, you have to navigate to that folder using CD and all DOS commands, right? Then you have to write Java -jar. Then I'll write name of my jar file. In my case, name of my jar file is mycalc.jar, right? So I'm going to say mycalc.jar, and that's it. And the code gets executed. So the same result I'm getting here, which I was getting when I ran it in Eclipse, if you remember. The same thing I'm getting. So my whole code is now will go and actually work on my father's machine without having him to install any of the Eclipse and all those things. And moreover, he doesn't even need to install JDK. So that was the difference I was talking about in the beginning of these slides in the previous sessions, about difference between JDK and Jre. Okay, JDK is used to compile the code. Jre is used to execute the code. Okay, so this is the difference between JDK and Jre, that is the compilation and execution. So JDK here, since I had to export it, I must have JDK, otherwise I couldn't have created this jar file, because jar file is nothing but the compilation, and I cannot do any compilation without JDK, right? But my father or my client or my sister doesn't have to install JDK. All they need is Jre. So if they install JRE, then it's fine. They can still execute the code. And this is what I was talking about when I was talking about this diagram. JDK, JRE, JVM. So there are two versions of Java. One is JDK, second is JRE. If you install JDK, you can compile the code. That means you can create the jar file. If you install JRE, you can actually only execute the compiled version of it, which is a jar file. So my father should have JRE and I should have JDK. So developers will always have JDK, clients will always have JRE. That's the difference. Fair enough, I'll come back. So now I don't want to really do these kind of things, this kind of building and all. So instead of doing that, I should be having a mechanism which is responsible for building my project. Okay. So I'm going to talk about Maven now, because Maven is such tool which helps me in achieving this. There are of course many other tools. So previously there were tool called as Ant, which also used to do the same thing. But now the more advanced version of Ant is, it's not the advanced version of Ant, but it's a whole different conceptual tool called as Maven. And we have one more concept called as Gradle. So Gradle I'm not going to talk about. I'm going to talk more from Maven perspective. Okay, and more or less Gradle and Maven almost works the similar way. So no big difference there to talk about. Okay, so next is my demonstration on how this Maven project or how to create the Maven project. Let me close all of these files. So to create a Maven project, guys, give me a minute.